What if you could take two of the biggest ideas in science fiction, teleportation and time travel, and just smash them together? I'm not just talking about zipping from one place to another in the blink of an eye. I mean zipping from one time to another. Now, it sounds like pure fantasy, right? But today, we're going to unpack a theoretical blueprint, one that's actually grounded in some real, mind-bending physics for how this just might be possible.
So, to really get our heads around this, we have to start with one simple, but seriously profound question. It really cuts to the core of everything we're about to explore.
I mean, what a thought, right? But before we can even try to answer that, we all need to be on the same page about what teleportation actually is to a physicist. Because I can promise you, it has nothing to do with those shimmering light shows you see in the movies.
Okay, so the key thing to get here is that we are not, I repeat, not, beaming matter across space. Quantum teleportation is all about scanning the exact, unique quantum state of a particle, all of its information, and then sending that information over to another particle somewhere else. You're basically reconstructing a perfect copy. And get this, the original particle is destroyed in the process, but an absolutely identical version just pops into existence at the destination.
And this really lays out the huge difference. The sci-fi version, that's basically a magic moving van for your atoms. But the reality? Well, it's more like an unbelievably precise subatomic fax machine. You're not sending the original piece of paper, you're sending the data to print a perfect, flawless duplicate on the other end.
So, how in the world does the subatomic fax machine even work? Well, it all hinges on two of the absolute strangest, most fascinating principles in all of physics. Let's take a look at the recipe.
First off, you need something called quantum entanglement. Einstein famously called this spooky action at a distance. Just imagine you have two coins and they're magically linked. If you flip one and it lands on heads, you instantly know, faster than light, that the other one, even if it's across the galaxy, landed on tails. That's entanglement. And this is the wild part, you also need a totally normal classical channel, like a laser pulse or a radio signal, to send over the last little bit of info needed to complete the reconstruction. It's this bizarre marriage of quantum weirdness and everyday tech.
Okay, so we're just transferring information, right? Not actual stuff. So how on earth could that lead to time travel? Well, this is where we strap in, because we're leaving the safety of the lab and diving headfirst into the truly wild world of theoretical physics.
So, physicists have dreamed up a few potential bridges that could connect teleportation to time itself. Now look, these are super speculative, but they're all based on theories we already have. So let's just quickly touch on each of these incredible ideas.
Let's start with the big one, Einstein. His theory of relativity proved that time isn't some constant universal clock. It's flexible. A clock near a massive object like a black hole actually ticks slower than a clock here on Earth. So what if? What if you had one end of a teleporter here, and the other end in a place where time itself is flowing at a different speed? If you jump between them, you wouldn't be traveling through time. You'd be skipping between 2 points on the timeline that are totally out of sync.
And then you've got wormholes, the ultimate sci-fi trope, right? These are, in theory, actual tunnels through the fabric of space-time. A wormhole could connect our galaxy to another, or it could connect this afternoon with last Christmas. So if you could send your teleportation data through one of those, you'd be sending information straight into the past or the future. The catch? It's a big one. We have absolutely no idea if they even exist, let alone how we'd find one and keep it stable.
So now, let's have some fun with this. Let's see what happens when we try to combine these theories into something a bit more concrete. We can actually sketch out a blueprint for a fictional but physically inspired device, a machine literally designed to teleport through time.
We're going to call it the Chrono Teleportation Gate, or CTG for short. Now, I want you to think of this as a conceptual model. It's a what-if machine that's built from the absolute wildest, cutting-edge ideas in physics today.
The design for this CTG has 3 absolutely essential and equally fantastic components. Each one is designed to tackle a different, massive piece of the time travel puzzle. You got to create the connection, you got to generate the time difference, and then you have to make sure the whole thing doesn't just, collapse.
First, right at the heart of the machine, is the quantum lattice core. Picture this thing as the mouth of the portal. It's this super-cooled, donut-shaped chamber, and its whole job is to generate and hold the bajillions of entangled particles you'd need to establish one end of this space-time bridge.
Okay, so wrapped around that core, you have the temporal field modulator. This is the engine of our time machine. Its job is to actually create the time difference between the two gates. And it would do this by using just immense amounts of energy to exploit Einstein's relativity, either by creating a crazy, intense gravity field or by accelerating the core itself to near light speed. Either way, time for that gate starts to slow way down compared to its twin. And finally, you need the space-time phase stabilizer. Look, if the connection between two different points in time is like a fragile soap bubble, the SPS is what keeps it from popping. It would have to use something purely theoretical called negative energy to literally prop open this corridor through spacetime, making sure that the link between the past and future stays stable long enough to actually send something through.
So, here's how you'd actually use the thing. Step 1, you create and entangle your two gates. Step 2, you use that TFM engine to make one gate older than the other one, creating a time gap, let's say 48 hours. Step 3, you fire up the SPS to lock in that temporal connection. And finally, step 4, you hit the teleport button. An object scanned at the present-day gate gets reconstructed at the other gate, appearing 48 hours in the past.
Now, as amazing as this blueprint sounds, we do have to come back down to Earth. The theoretical and the engineering challenges standing between us and a working CTG are, well, to put it mildly, they're astronomical.
Yeah, this machine is not happening tomorrow. For starters, you couldn't go back and see the dinosaurs because you can only ever travel back to the moment the machine was first switched on. The energy you'd need, we're talking about the entire output of a star. The connection itself would be unbelievably unstable, and the risk of a tiny data error when teleporting something as complex as a person, let's just say the consequences would be catastrophic.
You know, this idea really captures the entire concept perfectly. It's not a journey in a time machine like in the movies. It's a jump. It's a fundamental skip from one set of coordinates in space-time to another, where the time coordinate is just different. It's a completely different and frankly much weirder way of thinking about time travel.
And that brings us to our final thought for the day. Let's just imagine we solve every single one of those impossible hurdles, but the catch is we can only send information, not people. What one message, a stock market tip, a scientific formula, maybe a warning, what would you send back to try and change the course of history? It's a question that tells you as much about our hopes for the future as it does about our regrets of the past. That's it for this explainer. Thank you for watching.